Hello everyone, we're going to go over a couple of trig problems and making sure you know how to set up the visual and understand the difference between angle of depression and angle of elevation. So in the word problems that we're going to be seeing, they're going to be talking about different objects. Sometimes they talk about a person, sometimes they talk about a plane, as you see here. So it's going to vary. Now, a lot of times you think about a person and it's about what they're looking at. Usually they're going to be looking straight ahead. That's their normal line of sight. And if they look down, they're going to tell you what angle they're going to look down at. And if they look up at something in the sky, they're going to tell you what angle they look up at. Now, those two things have different vocabulary words. When you look down, it's called an angle of depression because you're down, you're sad. When you look up, it's called an angle of elevation. But it all has to do with this horizontal line. It all has to do with that horizontal line, if you're going down from that horizontal line or up from that horizontal line. So in each of your problems, you have to find where is that horizontal line that you're either depressing or elevating from. Now in this little diagram that we have here, we have a visual of a pilot in the sky. Now, as you can see, his normal direction is going to be directly to the west, and that's how he's normally going to fly. If he's looking down at something, like in this case, he's looking down at two guys that are in an observation deck. He's looking down at an angle of depression, because anytime you look down from your horizontal line of sight, that's an angle of depression. So they show you that angle 2 is an angle of depression. Now, the two guys that are in the observation tower, their normal line of sight is straight ahead as well. So anytime that they look up, maybe they're looking up at the pilot, they're forming an angle of elevation. Angle 1 and angle 2 are going to be congruent. So anytime they tell you about an angle of depression, that's going to be the same as the angle of elevation in your diagram. And the reason they're going to be the same is because of our very popular Zaro Z. That famous Z that tells you that the angles in the corners, the alternate interior angles, are going to be congruent because the horizontal line in the sky and the horizontal line along the ground or beneath it is going to be parallel. So those two angles are going to be congruent. Now it's all about drawing these diagrams correctly. So let's take a look at a couple of problems that we're going to work out and we're going to see how to solve. Okay, so here's our first problem. It says a 20-foot ladder leans against a wall so that the base of the ladder is 8 feet from the base of the building. What is the ladder's angle of elevation? Okay, so let's say we have a wall, and here's our wall. We need a ladder leaning against it, so I'm going to draw a ladder. Now it's going to be planted directly onto the ground. So I'm going to extend this ladder, okay? And it is a 20-foot ladder. So I'm going to have 20 feet as the length of this red line. Now, the wall's height I don't know, but I do know that the base of the ladder, which is right around here, is going to be 8 feet from the base of the building. So I'm going to put 8 feet along the bottom. Now, your wall is supposed to make you understand that it's going to be perpendicular to your floor. Now, the question is here, what is the ladder's angle of elevation? Angle of elevation. Now remember, you're looking for your horizontal line. In this case, your horizontal line is that 8-foot distance that the base of the ladder is from the base of the wall. So when it's asking for the angle of elevation, you're going to start that horizontal line, you're going to go up. This is the angle that they're talking about. It's this angle. So they're asking you, what's the measure of this angle? Now, when you try to find angle measurements, you're looking at trig functions that are the inverse of their normal function. So things that are to the -1 power. If you take a look at my calculator on the left here, you'll see there's a sine to the -1, cosine to the -1, tan to the -1. You're looking at those trig functions. So let's figure out which one we're going to use. We're going to label in our O, A, and H and decide which of our trig functions we're going to use. Across from the x value, across from our angle, the wall's height is the opposite. The ground floor distance of 8 feet, that's your adjacent. And then the 20 feet is your hypotenuse because it's across from your right angle. Now, we don't have any information about the opposite, and we're not asked to find it. So we're going to be using A and H, which means if we're using cosine. So we're going to write down cosine of x equals your adjacent over your hypotenuse, 8 over 20. Now the issue is we can't just divide both sides by cosine, something like that, to get the x by itself. We need to undo the cosine of x. And the way that we do that is by using our inverse trig functions. So we're going to do, to get x, cosine to -1, which is the inverse cos function, of 8 over 20 in order to get our angle. Now with these single line calculators you're going to be using on the EOC and the ones that you have on your phone, this is how you put it in. You're going to put in this fraction first, and you're going to see what is the ratio of 8 to 28. So in my calculator, I'm going to do 8 divided by 28. Okay. So my decimal, which is a little bit off the screen. Okay, so now that I fixed it, 8 over 28 gives you that decimal 0.28. Now you're going to try and figure out what is the angle that's associated with that ratio when you're talking about cosine. So we have our cosine to the -1 button already pictured here, but for some of you, you may need to press like second or shift, something that's on your calculator to activate these inverse trig functions. So all we need to do is we need to press that cosine -1 button. So that's 73.4 degrees almost. So that must mean that this is a 74-degree angle. That's the angle that this ladder must have as its elevation in order to reach the top of this wall. So our answer here is going to be 74 degrees. I'm sorry, actually, we're going to round down. 73 degrees if we're rounding to the nearest degree. So that's how you work with an angle of elevation problem where you're solving for the angle of elevation. Okay, so let's take a look at another problem. Okay, so a 50-meter vertical tower is braced with a cable secure at the top of the tower and tied 30 meters from the base. Okay, it's a lot of information though. Let's try to break it down. So a 50-meter vertical tower. So you want to draw a tower. Okay, now your tower is obviously going to be situated on the ground at a right angle. Because it's straight up, it's vertical. And it is braced with a cable secured at the top of the tower and tied 30 meters from the base. So it's going to go from the top of the tower 30 meters from the base of the tower. So maybe approximately here is your 30 meters. So 30 meters from the base. So the wire is going to go from the top of the tower down to the base. Okay. What is the angle of depression from the top of the tower to the point on the ground where the cable is tied? Angle of depression is what they're asking for. Now, your angle of depression, there has to be some type of horizontal that you can go down from. So it says from the top of the tower. So if I'm at the top of the tower, imagine I'm standing up here, or you're standing up there, and your normal line of sight would be straight ahead. If you're talking about an angle of depression, maybe you're looking down at where this cable is tied along the base. So if you're looking down, this is the angle you're trying to solve for. That's your unknown. Now again, we're going to look for our z because we want to get this angle to be inside of our triangle. So we can use some trig here. So this x value is going to be the same as this angle's x value down here because of the corners. So we're going to use this triangle now with an x value inside of our triangle. And we need some other measurements. So there's one thing that we didn't put in, and we didn't put in the 50-meter vertical tower. So we also need to put in that the measurement, right, the height of this tower is 50 meters. Okay, so now we have two measurements and we're looking for the angle. Now, according to our reference angle being x, which is down here inside of our triangle, the 50 meters is our opposite side. The 30 meters is our adjacent side. So if we're using O and A, that means we're using TOA, tangent. So we're going to write down, we're going to do tangent of our x value, our angle, equals our opposite over our adjacent. So the 50 over the 30. Now to just get x, we have to undo this tangent. So to get x, we're going to do tangent inverse, which is 10 to the negative 1 of 50 over 30. Okay, so in your calculator, we're going to do, clear this out, 50 divided by 30. Here's our decimal, 1.66666 repeating. We want to get the angle measure that's associated with that ratio, with that decimal. So we're going to click the inverse tan button, and it's going to give us 59 degrees. So that must be a 59-degree angle. So we're going to write down that this is 59 degrees down here for your angle of elevation, which means up here your angle of depression is also 59 degrees. And that's our final answer. Take a look at one more problem. Okay. All right, so for number 4, it says from the top of a lighthouse, 210 feet high. Okay, so we have a lighthouse here. Let's put in the measurement 210 for how tall it is in feet. The angle of depression of a boat is 27 degrees. So from the top of the lighthouse, so up here, your angle of depression is 27. Now, usually if you're going to be on the top of the lighthouse, you're going to look straight ahead. So if you're looking down at the boat, the angle of depression down to the boat, you're going to put your angle up here as 27 degrees, which means the angle down for your angle of elevation down here is also 27 degrees. Okay. Now, it tells us that this tower is probably going to be straight up high, so we know that's a right angle. The distance from the boat to the foot of the lighthouse is what we're going to try and find. This is find the distance from the boat to the foot of the lighthouse. So here's the boat. Here's the foot of the lighthouse. So that yellow line is what we're going to be looking for. The lighthouse is built at sea level. Okay, great. Now, let's go ahead and take a look at our triangle. So what do we have? We have an angle. We have the side opposite from that angle, and we're going to be looking for the adjacent side. We don't have information about the hypotenuse, and we're not asked to find it, so we're not going to use any trig ratio using each. So think about what we're going to use. O and A. Just like before, we're going to use tangent. So we're going to write down tan of our angle 27, because in this case we have our angle, equals our opposite, 210, over our adjacent, which is unknown. I'll call it A for now, some variable. Now, when we have our variable on the bottom, the trick that I've told you is this. You're going to end up switching your trig function with that variable. They're going to switch places. So you're going to rewrite this equation to be A equals 210 divided by the tangent of 27. Now, this is all calculator work, so watch how we put into a calculator. We're going to type in 210 divided by, now we need the tangent of 27. We're going to click the 27 button first, that's going to be our degree. And we're going to tell our calculator to take the tangent of that 27. So we're going to click tan. And you'll notice it's giving you a decimal. That's the tangent of 27. So becoming familiar with what a tangent ratio or a sine ratio or a cosine ratio should look like is going to be helpful. So that right there, that's just your tangent ratio. When you feel comfortable that, yes, your calculator is doing the tangent ratio correctly, then you're going to go ahead and press OK, equals. Do the division now. And we press equals and we get 412.2. Actually, 0.1, sorry, 412.1. So we're going to write down that A is equal to 412.1 feet. All right, so the answer to this problem is 412.1 feet. And then we're done.